All right, guys. So, like I mentioned, today we are doing our introduction for our laser unit for this class. This is very cool, and I think you guys are going to enjoy this. The workflow is similar to the process that we go through when you're sending a design to a 3D printer. However, the way that you design things to be laser cut, plasma cut, water jet cut, anything where we are cutting on a CNC controlled bed cutter. There's also, I'll give you guys an example of something else that works this way. Also, sticker machines and vinyl plotters, they also work this way, as well as machines that cut out flat pieces of fabric. Actually, you might not know this, and it's kind of like a hidden or unknown thing for a lot of people, but there are actually clothing manufacturers that use laser cutters for cutting out all the different flat pieces that go into sewing something together, like the shirt that I'm wearing, or backpacks, furniture, all kinds of stuff like that, that is made from flat pieces of material. So the workflow, again, like the process that when we send stuff to it is similar. The way with regards to the mechanics and the mechanical or mechatronic move, the right-hand thumb rule that we learned about still applies, and that is still the same. However, for the most part, we don't really move anything on the Z-axis up and down because we are cutting just flat materials. In some cases, with some of the machines that we're going to look at, it actually, the Z-axis is actually something that you move yourself. We're manually adjusting how far away the lens that does the final focusing of the laser beam, and we manually adjust that depending on the thickness or the type of material that we are cutting. So I'm going to queue up a video for us real quick. Before I do that, when you guys hear laser, what does that mean to you? What do you guys think of when you hear laser?
Like a straight beam of light.
Straight beam of light.
Some
Okay.
are harm, some are dangerous to use.
Oh, wait, you said some are harmless and some are dangerous? Is that what you
Yeah,
said?
you see those lasers that you see at clubs and parties, but some lasers can be actually dangerous. Yeah, some like that lasers. But lasers, the ones that are extremely hot and they can beam down, they can burn the skin or anything else.
Yeah.
Like you see those in James Bond movies.
Yeah. What makes you think of James Bond?
Because there was a scene, I think one James Bond movie, there was a giant lasers, and James Bond was captured, and the laser was beaming down. And I don't know, there was like a famous quote to it.
Yeah, it's funny that you say that, actually, because one of the videos that we're watching for our intro stuff actually talks about that.
Really? Wow.
Yeah.
Okay.
Yeah. Trying to get it queued up here.
I'm
not signed into my school account right now for YouTube, and it doesn't let me see certain things. So it's taking me a moment, but I'll get it going here real soon. All right, here it is. So just waiting for this ad to finish playing. I wish I could use my YouTube Red while I'm on the school account and just skip ads, but I can't. Luis says lasers that you can see with I'm not sure what that is. Night vision goggles? Is that what you're talking about? Yeah, I hadn't thought about that. So we know you know, kind of like a basic understanding that you guys have already is that lasers are light, right? And you might remember from maybe like a 6th or 7th grade physics class that there are different wavelengths, right? There's different colors of light that go into the light spectrum. Maybe if you don't know who Pink Floyd is, that band, you've at least seen the shirt probably. that has a triangular prism, and there's a beam of white light going into it, and out the other side is all the different color spectrums that go into making white light, right? So yes, it is light. Jacob said some are not really dangerous and some are more powerful and can like burn your skin, and that is correct. Any of the lasers that we're going to be using and learning about, including the couple that are right here behind me, right to the sides of this workstation, they are actually powerful enough to burn and kind of melt our skin. However, they all have built-in safety features where when the machine is running in a way that when the machine is running to actually cut or engrave things, if you were to open the door, it actually turns off the laser or reduces the power of it to basically where it's just a laser pointer, and the laser pointer doesn't really do anything to us, right? So we're gonna watch this intro video for our unit section, or excuse me, for our laser unit in this class. And while you guys are watching it, I want you guys to be paying attention and remember specifically what laser means. It is an acronym, and I want you guys to remember, take some mental notes. So you could write it down if you want. I'm not requiring you guys to do that right now, but you can. And take some mental notes on what laser means. All right, let me turn on my screen share.
So when it comes to lasers, you ever think we'll be able to make them so that we can shoot them out of our eyes?
Chuck, you see too many movies. Just get real.
How's this for real?
We've all heard about lasers. We know the word. You know it's an acronym.
Yes,
Yes.
I did know that.
Let me hear it.
Wait, how do you spell?
Laser, L-A-S-E-R.
Oh, okay. Light amplification by stimulated emission of radiation.
Bada bing.
There you go. Or stimulation of radiation. That's sexy lasers. Okay, maybe
We go
not.
back to 1917.
Okay.
Albert Einstein.
I love how you just ignored me.
Albert Einstein. Little do most people know that he basically introduced the physics concept of a laser.
Whoa, wait a minute. Are you for real?
Yes. And he should have got a Nobel Prize, but he should have gotten like 8 Nobel Prizes.
Exactly.
He got 1, but he should have gotten 8.
He should, right.
Okay, so one of them was writing down the equation that allows us to even know and understand that a laser can exist.
Wow.
Okay.
Wait a minute. So there were no lasers, and then he mathematically said, yo, check out this laser.
No. He wrote a research paper establishing the principle of the laser. The laser would take another 43 years before it got invented.
Oh,
That's how ahead of the times he
dope.
was. Okay.
Oh, my God.
Right. So the way it works is you have an atom and it has electrons.
Right.
And the electrons, if you excite the atom, can have an electron bump up to a higher level.
Okay.
Think of it energy. Think of it as like rungs of a ladder,
Right.
or floors of an elevator in a building.
Right.
Electrons can hang out.
They can hang out at higher level.
Okay.
So it's like deuces. I'm going out.
There you go.
Right.
So now there it is. Now the electron doesn't stay there. It wants to, the whole system wants to de-excite. And depending on the energy level, depending on the atom, depending on the conditions, the electron can stay there a short amount of time or slightly longer before it de-excites.
Okay.
Just that's basic electron transitions in atoms.
There you go.
Basic.
It gets excited and then it calms down.
De-excite. It calms down.
Right.
Correct. Okay. And it does that all by itself.
Oh, nice.
Okay, so now watch. If you send light with exactly the amount of energy to allow an electron to go from here to there, it'll get absorbed, the electron will go up.
Okay.
Then when the electron de-excites, it sends back out exactly that same photon.
Like a club that's reached capacity. Two
One go
people
in,
in, two people
go
out.
Exactly. And would it be the same? Would it look the same? This would have a photon with the same amount of energy coming out. Now, it turns out that the photon that excited this energy level, this is Einstein's brilliance, if you bathe this set of atoms in those photons will not only excite the atom,
Okay.
they will actively de-excite the atom.
Okay.
Just by being in the bath.
Nice.
It's a spooky fact.
That's kind of the reverse of being in the bath with me. I'm just saying.
So that's the spooky fact. That's the stimulated emission.
Right.
So there's the electron. It's going to de-excite itself
right.
on its own time.
On its own time.
Right. But if you put it in a bath of these photons, it'll make it happen faster.
Right. So it goes up and it comes right back down, but that's all contrived by the bath of photons.
It'll make it come back faster.
Right fast.
And by coming down, it emits another photon.
Right. So now.
So this
Oh my
builds.
God.
That's what I'm saying.
Yes.
That's what I'm saying.
Oh, this is so cool.
Oh, right.
Right.
Okay. So you create a cavity. A
Right.
very special cavity with two reflective sides, okay? So that when the photon of light gets created, it can stay in there
Right.
and go back and forth and get magnified by this phenomenon.
Right.
As long as this medium has these kinds of atoms that'll respond to that photon.
Right. So you're exciting the atoms, but you're amplifying the excitement. Oh, snap! Damn it! That's amazing.
And we just created the whole acronym, light amplification by the stimulated emission of the radiation.
That is amazing. Wait a minute. He figured this out without being able to test it.
He had an understanding of light and atoms and photons, and out came this calculation. It was a calculation.
Wow.
It was a calculation that should happen. And sure
And it
enough,
didn't
does.
happen until 43 years later.
We didn't make a box to have that happen till the early 1960s.
Wow.
Right. And so back then, lasers were like expensive and they were rare. And come the late 60s, early 70s, you know who had a lot of lasers?
Goldfinger?
Oh, Goldfinger. I forgot about that. Goldfinger. He had like some big diabolical,
Yes.
evil man laser.
Exactly. Like the best villain line ever.
Wait, is that the one where James Bond is strapped to
Yes,
a table
yes.
and the laser's coming
And
right up his business?
You expect me to talk? No, Mr. Bond. I expect you to die.
Was that the line?
That's what the line.
Dude,
That's a great line.
you scare me sometimes. you got to get out more, you know?
This is true.
So that's a big old laser, okay? So now lasers are like impulse items at Kmart, right? I mean, they're not something that you need like license to get or find in a laboratory because they got cheaper, better. And so now we have a low power household lasers.
Right.
You have very high powers that are still used in laboratories and things. Anyhow, so I never leave home without lasers.
I do know
Yeah,
that.
so I have an assortment of them here. So this is one. I got people who dope up my lasers
Oh, really?
up in the Bronx. You don't have people to do that?
No.
Okay, so this is particularly bright. So just look at, this is a dark shirt, okay?
Oh! Oh, Jesus. Oh.
So this is bright enough to...
I'm scared to look
so
at
when
it.
I use this at night, because I'm a planetarium director, this beam will go 60 miles into the sky.
Yeah.
And I can point out stars and constellations.
That is amazing.
Of course, it's dangerous for airplanes, and
Well, yeah,
you never do that. right.
I'm pretty sure that's illegal. Like, yeah.
No, I got
Well, I'm sure. Yeah, you know people.
I got.
I know. You know people.
So that's that one. So a little known fact: a red laser and a green laser of equal power.
Mm-hmm.
The green laser is brighter, even though they have the same power.
Right.
Because your retina is 2 or 3 times more sensitive to green light than it is to red light.
Gotcha.
So the same brightness, energy brightness, the green will look brighter. So my 2 lasers here are green because I'm pointing out stars in the night sky. So I can use the same amount of energy you'd have in your red laser, but it'll be that much more visible to everyone assembled. So lasers had originally industrial applications.
Right.
But still, like, what are you going to do with a beam that big? And so clever people started saying, hey, we can do a skin peel. So depending on the frequency of light that the laser is, it can have different penetration depths of certain materials, including your skin, right?
So you can actually figure out exactly how many
How
layers
many
of the
layers came
dermis
down,
you can go
you
down
can then-
and then burn that off.
Burn that off because it's a very high intensity light.
Right.
And so there's a lot of energy focused in one place because of this cavity that builds the light and then the light comes out. So there's that. And I keep wondering if Einstein only knew that in 1917, this brilliant concept would be used for cosmetic, for skin peel.
Right. I don't think, yeah. I just
wondering.
Right.
I just wondering. So these are some of the applications of lasers, and of course the military.
Well, of course.
Yeah, you get a pumped up enough laser, and you want to talk about Star Wars, you can go into orbit and aim it at the sensitive circuitry of an enemy or rogue satellite. And people think in war you want to blow stuff up. No, you just want to disable it.
Right. You can take it out.
Just take it out. So if there's some part of the hardware that's more sensitive than other parts, you hit a laser to it, and melts it, burns it, fries the circuit, the satellite's dead in the water. Got a couple more examples.
Okay.
Also in medicine.
Right.
So it turns out the hemoglobin, just blood cells,
right,
are highly absorbent in green light. So if you have a very intense green laser, you can actually cauterize an open wound.
Nice.
By this method.
Right.
Because that's the blood cells that you're trying to sort of stop wherever they're going. You can just basically you singe
fuse them.
Yeah, basically you singe that.
Right. It's kind of walled off.
Walled off, exactly.
A big beautiful wall of flesh. Go ahead.
Wall flesh. Okay. And you can have very high intensity lasers that are not just sort of killing a cell or burning it, but actually vaporizing it. So there's some lasers that are powerful enough to vaporize cancer cells if you've identified a tumor or the like. And so that gets us to, what else is there? What are we using lasers for?
How about when you look inside to scan your food at the supermarket?
Barcodes.
Barcodes.
Barcodes. So it's just a barcode. Right. So barcodes are just lines of different thickness.
Right.
And actually they're lines that represent a series of numbers.
Okay.
You could type in those numbers if you wanted and get the same information that's in the barcode.
Right.
But the point is a laser does, boop, it's got it, the price, it's built into the code.
So all the numbers are there. Boom.
It's all there. And you can get even more information if you make it two-dimensional, because a barcode is just one dimension.
Right.
All right. That's all. There's lines of different thicknesses in one dimension.
Right.
You can make a two-dimensional barcode, which is basically a QR code.
Oh, that's the little square.
It's a square
with
thing.
The Rorschach for the laser. Tell me what you see, laser.
So
I see my father never loved me.
So you know, it'd be cool if you had like a three-dimensional storage of information, like a holographic. So the 3D version of the QR.
Wow.
The QR is a 2D version of the barcode.
Right.
That'd be an interesting way. You
I
can store like boatloads of information in a three-dimensional barcode.
I believe we call that Neil deGrasse Tyson.
No, stop. So Chuck, are we done with lasers?
Yes. Yeah. As a matter of fact, I'd just like to take one of.
You're not taking my lasers.
Okay. All right.
My lasers.
In that case, maybe I'll just take the time to tell you guys about story blocks. Hey, do you know the key to making a professional looking?
All right, guys. So
yeah,
what is something that stood out to you guys about the video? What is a laser? Now you know the technical term, right? So what does laser mean? It's an acronym, right? You guys remember what that is?
I know the last word has radiation in it. It's
yeah, radiation. What are you talking about, Hugh? I'm guessing it's just really pixelized or not showing up very good. It must be just the internet connection. Let me try to get on Wi-Fi. This brick building that we're in is terrible. Usually it broke and it doesn't work anymore. So light amplified by, what was it? Stimulation. What's the E for? Stimulated emission of radiation. So in the simplest emission, there you go. E was for emission. You guys are gonna take, well, you know, when we do our little quiz about our unit, laser, and what that acronym means is definitely gonna be on there. So here's like the simplest way that you guys can think about it. A laser is just really excited light, highly amplified, focused, and concentrated light. That's what it is. So you guys have seen Toy Story, right? The very first one. You guys remember when Sid has a magnifying glass and he's pointing it at Woody's forehead and he leaves like that spot on there, right? You guys have seen that. That movie came out when I was a kid, but I know you guys all watch it too. So that light radiation that's coming from the sun, not that much different than the radiation that's in a laser. It's still light. And the reason why Sid was able to do that, and why maybe you at some point have taken a magnifying glass and and burnt some leaves or some ants out on a sidewalk, is because we are concentrating that light. So the light source is amplified, it is increased, and it is concentrated into that very, very specific small beam. Not all lasers are immediately dangerous, right? It is possible to have a laser that could burn your skin. When I'm using this little thing right here as a laser pointer, it's not doing anything to my hand, right? This is just like a little like couple dollar gas station thing. However, there are some things that we have to talk about because it is possible to hurt yourself. So I'm burning my insides. Luis said, point it into the camera. So I'm glad you asked. I wanted to try doing that. So I want you guys to think about this. So the laser here, if I was, my finger's not on the button, if I was to point this like directly in my eye, it is actually still bright enough to hurt your eyes, and you don't want to do that. Is your computer screen or your iPad screen, whatever it is that you're using to view this right now, is that as bright as a laser? Is your computer screen as bright as a laser? It's not, right? So when I point this, and I'll try to get it right on the camera, when I point this at the camera, is that the same brightness as looking directly at the laser? Yeah, it does get spread out. Yeah, it's definitely not the same brightness as looking at the laser. It looks really bright, right? Obviously, it's super bright. I'm pointing a light directly at it, but it really wouldn't be any different than just taking a flashlight and pointing it directly at the lens of the camera either. So a couple of things about lasers. So things like this, you know, this one actually has a warning. It says danger laser radiation, avoid direct eye exposure. And it says maximum output under 5 milliwatts. 5 milliwatts. So, or megawatt. 5 milliwatts. I think it's milliwatts. And it has a wavelength. It says it is a class 2 laser, looks like. So you still don't want to point it. We still don't want to point it directly at your eyes, but this is just a little laser pointer, right? It's something super dangerous. So 5 milliwatts is what this is. The lasers that I have right here, this purple one, this universal machine that we'll look at, that's actually a 40 watt. And they use a green megawatt or Modern Warfare. Is that what you're saying? Yeah. So you guys learned something about the green, right? The green lasers, right? It can be much lower power, but still be a lot visibly a lot brighter. And then this other laser over here, that is actually a 45 watt. That one's a lot smaller, simpler, more compact, and that's the one that we're going to get started with and looking at how laser cutters work. So you don't point it directly at your eyes. If you had a laser pointer, you don't point it directly at anybody else's eyes. When we're looking at it on the computer screen is not as bright as a laser, so it's not the same thing. Your computer screen does not magically become, you know, even when I'm looking at it myself on my camera, it doesn't like instantly become a laser just because it's a bright light. It's actually no different than if it was just like a full white screen at the brightest setting on your computer. But we want to be careful with that. When we're operating these things like the laser cutters and engravers, they are actually, these two are the two smallest ones that we have on campus, smallest in size and power as well. And they have built-in safety mechanisms. So if you're running something, you open the door, it actually turns the laser off, or it basically cuts the power down towards basically just a laser pointer. Okay, so we know kind of a little bit now about how lasers work, and we're gonna transition over there, and I'm gonna start showing you guys a little bit of the mechanisms of the machine. So you guys remember the right hand thumb rule, right? You guys remember that? Right hand thumb rule. Let me turn my camera around here. Let me see how I can make this lay down as low as possible. It's kind of reversed here. That's actually my left hand, and it looks like my right hand right now. How do I get this to turn around? I mean, yeah, it's fine, except for when we're looking at words here. Everything's gonna be backwards, right? It looks normal to you guys? No way.
Oh.
What does it say?
Something with.
I think you're just good at reading things backwards. Is it really directly? I mean, correct from left to right?
Maybe.
Not a maybe question. Weird.
Yeah, I think so.
So when I have it this way, it's fine. When I turn it around this way, how do we fix that? I've seen somewhere. A setting. We're flipping that around. Well, it is what it is. Okay. I don't know what just happened or at what point it switched, but it's fine now. So I just turned this on. And once this gets booted up, we're gonna look at a little bit of the basic operation of the machine. And one of the things that we can do with this one in particular is we can actually unlock the axis, and we are able to manually move this around. So remember our right hand thumb rule? This is actually very new. It's only like a year old, but you see all this stuff in here? It's all brown. It's actually soot and glue coming off of things like this wood when we're cutting it. So we're gonna do a little demonstration right now, and I'm gonna ask you guys to do this. Send me a picture. Send me a picture in black and white of something that you want to engrave, and we'll engrave it right here on this piece of wood in a few minutes. Send it to me on Remind. Black and white picture of something you want to engrave on here. Send it to me on Remind.
Okay.
There's no real need to clean that as long as there's no debris. What you see is just discoloration from the smoke that's burning into it. And we are able to remove stuff and get it cleaned out. So you guys remember the right hand thumb rule, right? Right hand thumb rule. X positive that way, Y positive that way, and then Z positive would be going up However, on this machine, there is no Z movement. The Z movement happens by manually adjusting the height of this little bracket in here that holds the lens. So we're not going to be doing that. It is right now actually adjusted for the thickness of material that is in there, but you're able to move this here. So this would be going in the Y positive direction, X positive direction, X negative direction. And this machine does not have a powered Z axis. So there's nothing in the Z axis that goes up and down. Thanks, Luis. So I'll get that opened up in just a little bit. So what we're gonna do as a little demonstration to get started with this is I will lock that back in. How much noise do you guys hear coming from the machine? Is it very loud? Okay, that's good. So there is some noise here. There are some fans running. And there, when we actually start it, you'll probably be able to hear some more noise with the air and water pump running. So on this controller, on this machine, we are able to actually move the axes like we were just talking about. And what I'm gonna do is with that piece of wood that is in there, I'm actually gonna have it take a picture of that. But do you guys see right now? Some of you can see that little red dot where the laser is being pointed out. Do you guys see it? We can try to get closer. Let's see how close we can get. Might have to take my phone off. You see the little red dot now? Yeah, so that's the laser, of course, right? However, right now, it's not doing anything. It's basically just powered down almost as if it is just a laser pointer. So I'm gonna home this. We haven't ran it in a little bit. It's gonna go through a little bit of a cycle here. And I will get linked up to the computer so that we can run it. All right. We'll see. Whoever sent it first is the one that's gonna get engraved, as long as it's not something inappropriate. Okay. It is gonna be the SpongeBob caveman, Luis. The image that you sent is actually, it has too much black. It has a black background, and we want to try to avoid that.
You should have told me. I didn't know there was a black
I
background.
know. You're right. You know, the instructions that I gave you were a little bit ambiguous. I'm sorry about that.
Call rematch. This isn't fair.
Rematch.
I won. I for sure won. I'm playing now.
Okay, so I'm getting that opened up right now.
May I ask who sent it first?
Bear with me for a moment, guys.
Mr. Robles. Hello.
Funny. So last year, what it was, Android and Okay. So I'm going to try to set this up in a way that you guys can see what's going on the computer. And I don't have a ton of space here on this desktop, but we'll get it going nonetheless. So I'm going to click capture, and the laser is going to take a picture of the material that is in there. So what it's doing right now is it just took a picture of everything that is inside the machine, which was that little piece of scrap wood. Somebody had cut something else out of it. And there it is. So I'm just going to go ahead and say done with taking a picture. And then I'm going to import the picture that I saved that Hugh sent in. So here it is. Shrink it down a little bit so it fits just a little bit better. And then we have a couple settings on here. We're going to learn a lot about these different settings. I'm going to bump it up just a little bit. And then we're going to go ahead and send it now to the laser. I'll click start, send to cutter, and I'll turn my computer, my phone back around over here, and we'll be able to send it. So there's a couple things going on here. We're going to start learning about that. And here's what those things are. The laser cutter, we know, has motors. You guys saw also right? You guys saw the belts, the pulleys, the track, a lot like the 3D printer. The right-hand thumb rule applies for the x-axis and the y-axis movement. In the case of this one, there's no powered Z movement. So mechanically, the way it moves is very similar. The workflow, very quick example that we just went through with the caveman SpongeBob. There is a file that we send through a software that then sends the commands to the printer, except we're gonna be engraving here on a piece of wood. It's gonna make some smoke. So I'm actually, there's a air purifier system basically here. We'll learn more about that later, but I'm gonna turn that on. It's gonna get a little bit louder while I'm doing that. Okay, so I'll try to put this in a place. I'm switching back over here to my computer for a moment while it's running because it actually has about 7 minutes left in that runtime.
All I can see is this caveman SpongeBob's face.
So thank you for telling me that the camera was zooming in and out. It was because of the gantry of the laser that was going forwards and backwards, right? Coming closer and further away from the camera was making it come in and out of focus. So what is the basic premise of what this is doing? We took a file, that file processed it, or the software for the laser processed that file into instructions or commands, much like the slicer software for a 3D printer takes your CAD file and turns it into G code for the 3D printer to make your parts, except in this case, it's sending the instructions to the laser cutter. The same basic process underneath the surface though. It's sending commands of X and Y movements. And in addition to that, it is also sending commands of when to shoot the laser down at the wood. So much in the same way that a magnifying glass in Sid's hand burned that spot on Woody's forehead, as the laser gantry moves back and forth,
the program knows when to shoot the laser at a higher level or with more heat, and it is burning with light, very, very concentrated light. It is burning the image into the surface of the wood. This is actually also able to cut wood. And basically, there are two primary settings. You guys remember when we looked at primary settings for your FDM printed parts? There are basically two primary settings that we control when you're running a machine like this, whether it's a laser or a water jet, a plasma table, any type of machine that cuts flat material, and it's controlled by a computer. And those are the intensity or the power that we're cutting at. So in the case of the laser, the power of the laser, and then also the speed that the laser is moving at. And the combination of these two things, the depth of the cut, like how far the laser is penetrating or burning into the material, is a function of how fast you're moving and the power of the laser. So if at any time, for example, you want to cut thicker material, or you wanted this to engrave deeper or darker into the wood, you can do one of two things. You can bump up the power, or you can slow down the speed, or a combination of those two things to achieve the exact cut or the engraving depth or darkness that you're trying to achieve. So you'll notice here, as it works its way further down the image, it's taking longer as it sweeps across from left to right. Now, we're going to go through this whole thing in this unit, looking at different materials that can be laser cut, the process or how you select or know what can be laser cut or not. And there's a lot of materials that can be cut, not just organic materials like wood and paper, but also we can actually cut on different types of plastics and rubbers. In the case of these lower power CO2 lasers, we can do plastics, we can do different types of rubbers. You can cut and engrave leather. Leather doesn't smell very good when you're burning into it. It's basically burning skin, right? And we'll learn about different features and functions as we go through it. Yes, if you've ever burned yourself really bad, or I don't know, maybe threw a glove in a campfire or something like that, doesn't smell good. So right now, currently on campus, I've mentioned to you guys earlier in our semester when we did a tour of the facility that we have 4 lasers. This is actually the smallest laser. The overall work envelope of it is about the size of an 11 by 17 piece of paper. And it also only has, I think it's right about 2 inches for the work area, or how deep or how thick of material that you can put inside of there. This is only a 45 watt laser. It is not very powerful. It is powerful enough to cut some of this thin wood and plastic, leather as well, but it is not a very powerful laser. So we have that one, that's a 45 watt. We have right next to it, it's actually a bigger machine, but slightly slower power, slightly lower power. That's a 40 watt machine. And then the other ones that we have on campus here right now are a 75 watt and a 150 watt. So to give you guys a little bit of perspective, the machine that we're running the SpongeBob Caveman in right now, the maximum thickness of wood that can cut is about 1/8 of an inch, or what's in there right now. It can go a little bit thicker than that, but not by much. 45 watt, about 1/8 of an inch. The 150 watt machine, if you were cutting wood, just to do a direct comparison, can actually cut plywood over 1/2 inch thick. We have cut 5/8, I think. 5/8, definitely at least 9/16 thick plywood in that one, and it just zaps right through it. It's pretty cool. All right, it's almost done with the SpongeBob caveman here.
Looks amazing. Wow. Wow.
I don't think he knows his mic is muted.
Mr. Ripple, your mic is muted.
Yeah, I just saw that I was muted. I was talking about how this one moves pretty quick, and we jogged it out of the way. So we moved the gantry of the laser back into the back left corner so that we can get in here and lift this up. So because we were running this air purifier thing, it's actually connected with a duct to the back of the machine, and it's sucking out all the fumes. But when we're cutting, and it actually goes all the way through the wood, like you see here, that's when it's leaving all that smoke mark on here. This is actually, it's actually pretty clean. I'll show you guys over here this other machine in just a moment. But there it is. So you could actually, I'm pretty sure, if we can get the camera to focus here. So you guys can see, hopefully, how the image is kind of etched into the surface. The surface is burned down into it, right? And basically what's happening is, you know, in a very, very small way, but similar to what you might have seen in a sci-fi movie, maybe in Star Trek, and shooting a phaser gun at something and having that just evaporate and disappear. The heat from the laser is evaporating essentially and burning away the material, and then we're able to see that image burn into it. It does have a depth to it, and it is engraved. And I was talking about how different power levels and speed can achieve different depths of cut and darkness of engraving. You are actually able to achieve a gradient or have a kind of a 3D or shaded effect by having some parts shaded in at different darknesses or different shades of black and gray to make different depths of engraving. So there's that real quick. A couple of you guys asked about how dirty this looked. So you can kind of see over here towards this corner is more black. So like I mentioned, this machine is about, I don't know, it's about 1.5 years old now. This one here, this was the first laser that we got on campus back in, oh man, 2014. So it's been a little while. This was about 7 or 8 years old. And you can actually see, it's time to turn this one around. So that honeycomb support is actually so burnt up. You can actually see it has started to deteriorate over here in the back left corner.
Don't you have to
So
clean
again,
it?
guys, look, I want you guys to remember how the right-hand thumb rule applies to this, right? So that's X positive, Y positive, Z positive that way. There's no purpose of cleaning this here. As long as we are removing debris, the discoloration doesn't affect anything and is part of the normal process. So knowing how the right-hand thumb rule applies to this, what corner would this be over here? If this is our origin, what quadrant are we cutting in?
The I forgot. But I was gonna say that you're starting at the left corner.
Yeah, quadrant 4. So the bottom right quadrant. Yeah, when we're laying things out and we'll look at a later time, we'll look at the different settings and features in the programs of how these work. Normally, you don't really have to worry about the exact measurements because you can cut on a relative scale, which means that basically you just set the origin of the laser and you tell it start right here. And if your image is, let's say, 3 inches wide and 2 inches tall, then it would just travel those 3 inches across and 2 inches down based on wherever you told it its starting point is. So hopefully with this, you guys are starting to get an understanding of what we're going to be doing in the laser unit in our class. It's pretty exciting. I love doing this when we are here on campus, and I'm looking forward to you guys being able to experience this when everybody gets back to campus, hopefully in the not too distant future. And the reason why is that once you guys learn how to do this, everyone's always engraving their phones, engraving phone cases, engraving wallets, all kinds of stuff, engraving water bottles. I think I showed you guys a cup, right? So this VW logo that I have in here, we actually engraved that in this purple laser right here behind me. You're able to engrave and etch all kinds of things. And we start doing a lot of that, you know, passing periods at lunch, after school, before school, stuff like that. Once you guys learn how to use this equipment, it's really cool. I'm looking forward to everything that we're going to use in this unit. And so remember, laser, anytime we're talking about lasers, it is an amplified and concentrated light. Yes, Luis, what's your question?
Do you think I can engrave something into my Damascus?
Can you engrave something into your Damascus? Yes, definitely. I'm gonna put my headphones on so I can hear you guys a little bit better through my phone. So that's a good question. Yes, you are able to engrave metals. These particular lasers that we have right here. Dropped my eye drops. I wanted to make sure I didn't roll over them with my chair. So these particular lasers that we have right here, they're actually relatively low power in comparison to the grand scheme of things. But so these two are not able to cut metal, but they can engrave metal. And depending on the metal that you are engraving, I just run the laser directly on it with the image, with the logo, with the words, or you can apply a compound, an engraving compound or marking compound that allows you also to engrave on polished surfaces. So yeah, it is possible to do that. However, but I wouldn't have you bring that into the classroom for us to engrave that, right?
Obviously, but what about knives?
What about what?
A chef's knife?
A chef's knife? No, I wouldn't bring a chef's knife to campus.
Oh, do I?
You might get yourself in trouble. If you were able to like remove a handle off of it and bring the handle in, then maybe that would be safe. I'd rather be safe than sorry with stuff like that because it's too easy to get into a lot of trouble for something, you know, very small.
Okay.
All right,
What about-
guys.
Wait, what about a pocket knife?
No, we're not gonna engrave pocket knives on campus.
No? Okay.
No. Actually, there's a couple different places around town, like maker labs. So we kind of have like a maker space here on campus, right? In the sense that we have a lot of things that you might see at a maker space. And there are places around town where you could actually go in and use the laser cutters, a lot like what we have here. It's not a school, it's like a membership type thing. And so if you want to try do that, you could do that. Also, I typically talk about like the cost of entry if you wanted to do some of the stuff yourself. This little laser here, these ones, this is a Dremel, but there's another one called Muse, and those are in the neighborhood of like $2,000 to $3,000. But if you go look on Amazon, there's actually some smaller ones, and there are lasers that you can use for engraving things that you can get on there for like a couple $100. So something cool to check out. I'm gonna leave you guys with some homework here, and I'm gonna stop our recording for this lesson in a few moments. And your homework is this. So you know already that one of the basic applications that we can use lasers for is to create something by cutting and engraving. So this is, people usually call these laser engravers or cutters. You already know that. That's kind of like our given for this class. But I want you guys to do some research and find other applications that do not involve cutting and engraving. What are some other applications of lasers? Okay, so I want you guys you can go do some searching on YouTube, on Google, find other applications of lasers. You may have already seen some hints of that on the video that we watched for the introduction with Neil deGrasse Tyson. So I'm gonna stop our recording here right now, and then I'll give you guys some follow-up instructions. All right, guys, I'll see you.